Hola, good morning here, but I heard it's good evening in Peru. So, buenos noches. This is Eugene Kim from SATREC Initiative, the high performance small satellite company from Korea. I'm overseeing the international businesses and programs from my company. I would first like to say thank you to Conida to organize this webinar and inviting us to give us an opportunity so we can share the story of how Korea is tackling its national problems, in this case, national security problems, by using satellite technologies and how we are contributing to this. Okay? My presentation today, contents of I will first start uh, by telling you about the situation in Korean Peninsula, and then how we are contributing to this. Well, to briefly introduce the company and what we are doing to solve this problem, and also a constellation that we can form, we are planning to form for national security before I wrap up my talk. So the national problem situation in terms of security, I'm thinking some of you might have seen a picture of Panmunjom on the right, which is located in demilitarized zone between North and South Korea. I think we are pretty much the only country in the world which is divided into two. We've been divided since 1953, so almost 70 years. Although we are not shooting at each other every day, we are technically at war under an armistice. So there have been still, until recent years, threats and hopes. Until like 3 years ago, North Korea kept launching their long-range missiles, which can target anywhere in South Korea and also neighboring countries. And so South Korean government decided we need to do something to talk to them. So on the right is the South Korean president, and on the left is the Kim Jong-un, the North Korean leader. They shook hands for the first time. No, not for the first time, for North and South. They shook hands, and this led to a first ever talk between the two leaders of USA and North Korea. We'll see how President Trump exits his office, but this was an historic moment. But unfortunately, it did not end very well. It's still stuck, and the peace talk not moving very well, I think. The main reason is North Korea has been developing nuclear weapons and long-range missiles to carry them. It's a threat not only to South Korea, but they are developing intercontinental ballistic missiles, which can strike USA. So I think they're using this as a card so they can talk to the USA. They think this is the one and only card. So for South Korean government, we had to develop a way to watch them closely and monitor what they are doing in terms of nuclear tests, tests, and also missile. And one way to monitor them is by adding more eyes in the sky, in space. So they've been investing in Earth observation satellites. You can see COMSAT-2. Their Korean government satellite name is COMSAT. COMSAT-2, COMSAT-3, COMSAT-3A, and COMSAT-5. Left three are optical satellites, and one on the right is a radar satellite. And they all have resolution of 1 meter or better, sub-meter resolution. So that's what they've been doing this. And each satellite, I think, weighs thousands of kilograms, and very expensive satellites. But Korean government is moving in a different direction as well in the so-called new space era. As you know, new space is characterized by more involvement led by private companies than government, and also by launching smaller and a lot more satellites. So we can for example, take pictures of North Korea a lot more often. And South Korea agreed with USA so they can launch solid fuel rockets, which used to be used for missiles. But now we can use this as a satellite launcher, and we can launch a lot more small satellites. They call it unblinking eye, the South Korean, the Blue House, the equivalent to White House of America. Blue House announced the unblinking eye plan by launching a lot more small satellites. So it's almost for continuous observation, right? So we've been heavily involved in this plan as the most prominent satellite company in Korea. So I will talk briefly about how we got to this point, how we started, and what we are doing, how we are contributing to this government program, right? We started as a small research center within KAIST, a famous technical science and technology university in Korea, by sending 27 students abroad, learn how to build satellites and how to build satellite-related satellite payloads. It was serial number 27 of them, and they came back. They launched very first Korean satellite called KitSat-1 in '92. And after building 2 more satellites, we spun off as a commercial company in the end of '99. So, this picture shows the KitSat-1, the very first South Korean satellite. The founder of my company is in this picture, second from left. And this was 50-kilogram satellites. We learned how to do this from University of Surrey of UK, the pioneer of small satellites. And this kind of shows the quality of pictures we took at the beginning. KitSat-1, I think kilometers of resolution. You can see the Korean Peninsula. Fast forward about 30 years, and these days, this is the quality of pictures we can take by the satellites we are building, by the satellite and payload we are building these days. It shows Pyongyang, capital of North Korea, where the North Korean leader lives. It shows a square right in front of the palace where he is living. I think they're doing preparing for a parade. This was taken by Deimos 2. We built for a Spanish company. And after the post-processing, they distribute the image with 70.75 meter resolution. We started as a small research center, but these days we are one of the most important small satellite companies in the world. And we've been in space industry for over 29 years, starting from Surrey days. And we've been involved in more than 32 projects, both international and domestic. We keep hiring people, and as of this week, I think we reached 360 people, including 2 daughter companies. As a group, we reached 360 people. We are following the major international standards. So we started we've been all along with Korean space development history, starting from very first satellite, KitSat-1. So after building KitSat 1, 2, and 3, launching 3 satellites, we decided to spin off as a commercial business. We believed that there's a market for, there's an opportunity for us and in the world. So we've been involved both in Korean government programs, ComSat series from ComSat 1, mainly for the ground segment. I'll get back to this point later. And then you can see in this picture, the satellites with red font is for the satellite systems we delivered outside of Korea. And the blue fonts are the ones we supplied the optical camera. So you can see we're pretty fully booked. And most recently, we started a microsatellite constellation. I think the picture that I showed you for Korean government, 11 satellites to form a constellation. So that's what we have been doing and what we will be doing. That's how we are involved with an effort where most of them are Korean national security. Our customers and partners are pretty much scattered around the world. And we have one partner in South America. Hopefully we can work with Peru as well. This slide shows the overview of what we do, how we are involved in an effort, Korean government effort to tackle the national security problem. So we do our own satellites and also our own payloads, the hardware, and we do develop our own software for ground stations, control and process the image, control the satellites and process the image. We have a daughter company called SI Imaging Services, which distributes the Korean government satellite imagery outside of Korea. And we have a daughter company called SI Analytics, which develops the AI algorithm to automatically detect objects, help fast decision making, right? I'll come back to these daughter companies. Satellites we have been building, which this shows one direction. One direction is for the quest of the better resolution. From left to right, you can see the resolution. It's getting better, 2.5 meter, 1 meter, half meter, and 0.3 meter. And one side branch is wide swath observation suitable for agricultural use. And finally, the most recent branch is smallest satellite, but this is not CubeSat level small sat, but Space IM weighs about 60 to 80 kilograms, but it comes up with a very high resolution, 0.8 meter resolution. So mainly we are moving into two directions. One is for the best resolution we can achieve. The other spatial resolution, and the other is for the best temporal resolution by launching a lot of them. Okay, this slide shows the relative sizes of the satellites compared to human size. So you can see Space IM is about 1 meter high, 60 to 80 kilograms, and Space IT is over 3 meters, and the weight, the mass is about 650 kilograms for the best resolution. Okay. So you can say Space IM is our iPhone, and Space IT is our Canon digital SLR with big telephoto lens. Right? The strength of us, we believe, lies in our capability that we can design and develop pretty much all subsystems that goes in the satellite. I think SpaceX shares the same philosophy that if we can build our own subsystems, we can optimize the best performance and also reduce the price, and we can make our satellites very compact. Yeah, and ground systems comes in mainly two parts. One is for the mission control station, which is used to control the satellites. For example, to command the satellite in orbit, to take pictures tilt the satellite and take the pictures at certain target, at certain schedule, according to certain schedule. So that's how we are controlling the satellite. And also, we need to monitor the status of health of the satellite, whether to check the temperature of each key component, and whether it's suffering any anomaly. So it keeps sending the telemetry to the ground, and we check the status of the satellite. And the other big subsystem is called image receiving and processing station, which is used to receive the image data from satellite. And we need to go through a lot post-processing to produce standard image quality taken by our satellites. Like I said, we've been involved with all Korean government ComSat ground systems. This shows ComSat 2, 3, 3A, and 5. The first three are optical satellites, and the last one, 1 meter resolution, 0.7 meter resolution, 0.55 meter resolution. And ComSat 5, which is a radar satellite, we delivered the military version, mobile version of the ground station to the Korean military, in operation right now. So this table shows a track record. Well, starting from ComSat 1 days, we've been involved in pretty much all ComSat, in literally all ComSat series, and some other foreign projects. And it's not here. These are all delivered systems, but we are right now building ComSat 6 and 7 for Korean government. the next and programs. Those were the ground stations, and these show the satellite side and payload side. CalifaSat was launched in 2018, 0.7 meter resolution. We built the optical payload, some key components, and ground station also for this. Helios 1 was a Singaporean mission. He supplied the 1 meter resolution optical payload. Deimos 2 and DubaiSat 2 are two twin design satellites, 1 meter resolution. And Deimos 2 to Spain. And after post-processing, they distribute the image as 0.75 meter resolution. Okay. And some sample imagery taken by our satellites we built. Satellites we built. Lara Oil Refinery of Peru, taken by Helios 1. This is a black and white payload. And most recently, the devastating explosion in Syria, Beirut, Syria. I believe on the left was taken by CalifaSat. On the left was taken by late last year, and on the right, so before and after, was taken by taken in August this year. And you can see before and after pictures. And this was done by one satellite, but if we form a constellation, we can take a lot more often than that and keep closely monitor what's going on in the region of interest, right? Okay, back to subsidiary companies, SI Imaging, which operates ComSat satellites. And because ComSat is a Korean government program, it's a long-term commitment by the Korean government. And in fact, SI Imaging, we were the second to Digital Globe a few years ago, Digital Globe, who could supply 50 centimeter or better imagery. ComSat 3A, after post-processing, we apply 40 centimeter resolution. AI Analytics develops AI algorithms for geospatial analytics of satellites and UAV, unmanned aerial vehicle imagery, for analysis of vast amount of imagery, automatic detection of airplanes, ships, cars, vehicles, for military intelligence, illegal shipping, and such. So the level of technology, as most recent good news from us, is we've ranked 5th out of 2,000 individual and companies competitions submitted by individuals and companies in XView 2 challenge held by Defense Innovation Unit of US Department of Defense. I heard only 2 companies above us were 2 US companies, which one of them was Mapbox, and the other was Lyft. Lyft is a competitor to Uber. They have interest in this kind of technology too, right? And we keep constantly win trophies in international competition, developing such algorithms. Okay, back to North Korea, our northern cousins. Typical way to launch their satellites is by using a mobile launch pad called Transportable Erector Launcher, or TEL. And what we do using the artificial intelligence algorithm is to detect probable objects by training and It gives you the probability, gives you the numbers, how close this looks like a missile vehicle. This shows an example of a case, and case of detecting 20-meter missile vehicle. So that's how we are helping Korean government to use satellite technologies, AI technologies for the in terms of national security using, yeah. And a bit more about the specifications of the satellites we are building suitable to form Constellation. Space IM is a very high resolution optical camera. Comes with a camera for optical camera for the best or 0.8 meter resolution at 500 kilometers. Comes with a 300 millimeter aperture. That's pretty much the largest in its class. And it comes with a push broom type. And the weight is about 60 to 80 kilograms. So it's a microsatellite, which is very suitable to form Constellation. Space IT, our largest satellite, and comes with the best resolution. We call it ultra high resolution, or 0.3 meter or better, well, depending on the altitude. 600 kilometers altitude. 14 kilometers of swath, and 0.6 gigabits per second downlink speed. That's one of the highest speed in its class. And its size is about 650 kilograms. So it's, I believe this is the smallest satellite that can take 0.3 meter resolution imagery. And this kind of shows the current state of the art in the world. Of course, Airbus, you see Airbus and Maxar. Airbus is building Pléiade Nail for 30 centimeter resolution. And Maxar is building Worldview Legion to tackle the 30 centimeter imagery market. And I think we are the smallest. The other two weigh 750 kilograms, both. And yet we carry even larger aperture camera than Maxar. Okay, so this is an example of how we can form a constellation for Korean government. We are already started working on this constellation on the left, consisting of space IM, or frequent observation. And when we detect an anomaly, on the right side is space IT, which is a larger satellite, and which we can use to observe the area of interest under more closely with higher details. So an example of constellation. Okay, so to summarize my talk, Korea has been using satellites for national security, and in the age of new space, Korea plans to launch a lot more high-performance small satellites to increase temporal resolution, meaning take pictures a lot more often. SATREC initiative, we've come a long way, starting from a humble beginning to a world-leading satellite Earth observation company with vertically integrated technologies, including the satellite, ground stations, imaging services and AI-based analytics. And we believe the future of satellite-based intelligence, surveillance, and reconnaissance is by combining the high-performance small satellite constellation and also artificial intelligence technology, which and that's how we are helping Korean government to solve the national problem of security. So that pretty much wraps up my talk, and I'll be happy to take some questions. Okay, thank you.